Sometimes you want to know the answer to a question, and Google doesn't have the answer, and you have to figure it out yourself. That's what I had when I wanted to know what each photograph the James Webb Space Telescope will take would cost. So it took a bit of time, but I'll give you my conclusions, and then I'll tell you what how I arrived at them. Version 1 of my estimate. $342,000 per photograph, give or take a bit. That's my estimate for what it might cost per photo. As far as I can tell, in its whole life, it's going to photograph perhaps less than 1/500th of the whole sky in all directions, you know. And in that time, it's going to take 29,200 photos. So, I was kind of surprised. It's a big number. Like, when I initially, before I crunched the numbers and did the maths, I actually thought, it's going to be up there a long time. The cost is going to work out at like $2,000 per photo. You know, still expensive, but you know, it averages out quite small, but that's not very small. So here's the breakdown. I've assumed the mission's going to take 10 years and there's a cost quoted of $10 billion. They say there's 20 years of fuel, but I'm ignoring that because I've got to make some guesses, and I think that some of my guesses are going to cancel each other out so that my figure's sort of accurate. When you're looking through the information about the sensors that they've got, the figure comes up a lot of 10,000 seconds as exposure time. So I'm going to call that 3 hours per photo. It's looking at something far away that's quite dark, so it makes sense, 3 hours a photo. I'm going to ignore the time to reposition the telescope between photos. So I've already rounded up from 2.7 to 3 hours. I'm going to ignore downtime. I'm going to ignore having to take loads of exposures of the same area, or the sensors looking at different things. I'm going to ignore all of that because I don't know how to do the maths if you take all of that into consideration, and there's just too many variables. So, cost. 10 billion. Number of photos, well, every 3 hours out of every 24 times 10 years, 365 days, 29,200 photos, which gives the cost I gave before, $342,465. It's expensive. So then I get into the harder bit of the next bit, which turned out to be real ridiculous because I made a maths error and it took me a long time to spot. It looks like, in terms of how much area in the sky, astronomers use this thing called arc seconds and arc minutes because a degree is too small. Like, they say that this telescope, the resolution of one of the sensors is 1/36,000th of a degree. And that's quite small. So, yeah, you can't use degrees. So if you think of like hours have got 60 minutes and minutes have got 60 seconds, a degree has got 60 arc minutes, and an arc minute has got 60 arc seconds. So that's how they use arc minutes and arc seconds. It's just subdivisions of degrees. So 9 or 10 arc minutes squared is what a number of, it looks like that's how big the photos are, roughly. Tiny. So over 29,200 photos. It's capturing a decent amount. Sounds like a lot, but it's not really. So yeah, it's coming to a 500th when you crunch the numbers. By comparison, compared to the moon, if you look at the moon in the sky, imagine a circle 20 times the diameter. Make the moon bigger. That's as much as this thing is going to be able to photograph in 10 years. I found that quite interesting. But then I was not sure if my maths was correct and if this was making any sense at all, so I decided to cross-check it with what was going on with Hubble. And one of the famous photos, the Hubble Deep Field photograph, that was assembled from 342 exposures that took 10 days. So whichever way you take it, 34.2 exposures per day is 124,915 exposures over 10 years. And if you look at the 10 days per photo, it's going to be able to output 365 photos. So whether you're looking at exposures or the finished composite images that we use, my estimate was 29,200, so I feel like I'm in the right ballpark. So anyway, I found that interesting. I hope you did too. Let us know in the comments if you've got an opinion on where you think I've got this right or wrong, because it's version 1 of the estimate. Cheers.